Guys, so we are already in day 8. This is a really important day to really stay focused here, okay? This can be a little bit more challenging, and so I really need your all-in focus. And this is going to be about U substitution. So while we're integrating, sometimes we have to manipulate the integral to get it into something that we can actually integrate. And that's where a U substitution comes into play. So here we a lot of times have it in terms of x's, and so now we're going to change it to u's. So if we change our u's, don't forget to also change your bounds to u limits from x limits. And I always like to say, if you change your bounds, don't go back to your x, okay? So we got to kind of get this in. So let's see what this is. So basically here, I'm going to look and see, wow, this is nuts. I don't want to have to, I could rewrite this whole thing as the power rule, but I'm not going to. So I'm typically going to look at the inside of the function and make that my u. Then I take the derivative of this u, and that's what I am going to make as my du. Well, I can see that I only have an x squared dx. So I'm going to take the 3 over by division. So now where I have that x squared dx, I'm going to put in a 1/3 du. Well, I like to just go ahead and put that 1/3 out in front. I had the inside was a u raised to the, oh, that was hard to see. I can't really see it. To the 4th, okay? And then I still had my du. So I want you to see how all of this substitution came into play. So I saw that the x squared dx became 1/3 du. So I got that taken care of. I said this inside is a u. I never did anything to the power of 4th, so it is still there. And now this is something that I can easily take the antiderivative of by doing a power rule. So let's look here. A lot of times we want our u to be the inside of a function and or the denominator. Well, in this case, it is in the denominator, but I only want to look at the inside. So I'm going to make my u be my x squared plus 5x plus 1. Then I always take the derivative of whatever I picked for my u. So this derivative is now 2x plus 5 dx. And holy moly, look how beautiful that is. This whole thing now becomes my du. I never ever did anything with the integral. So that's not integral, sorry, radical. So that stays. And then the inside of the radical I said was u. And now this is something, again, I can easily take the antiderivative by manipulating to the power rule. Okay, let's look at our next one. I'm going to take that inside to be my u. I'm going to take the derivative of that to be my du. And then I'm going to try to see what I need. Well, I need a dx over the square root of x. So I don't need that 2, so I'm going to multiply it over. So now where I have that part, I'm going to put a 2 du. And you can put the 2 out in front, like I said before, if it makes your life easier. And then that whole inside was the u, and I never touched the power of 3. So I want you to try 3 and 4 and see if you can get to the correct u substitution. Okay, so when you're ready, I want you to talk about this one. So why is this one so much better than this one? Well, on this one, I can rewrite to the power rule because I can do a heartbreaker on this. Over here, I cannot rewrite to any kind of power rule. It doesn't work, okay? So that's why we had to kind of get it to where the binomial was on top instead of in the bottom, all right? Okay, so if you would need more help on picking the U's, then go ahead and try this and look at my notes and see if you have it. If you feel like you're doing pretty well, then we're going to go ahead and jump to this first full out example. Okay, so here I'm going to pick the inside to be my U. I can also see when I take the derivative of the inside, it's going to go from a power of 2 to a power of 1, and I've got a power of 1. That's another little hint for you sub. Then I take the derivative of what I just had. Then I say I only have an x dx, so I need to get that over on the other side, so I'm going to divide. And now I'm going to rewrite my integral. So that would be the negative 1/2 du u to the 5th. Make sure that's what you got, and that's okay. Now here is where you cannot put 0 and 2. Those are bad now. These were from x's. We are not in x's anymore. So we have to now go find the u bounds. So my u, I need to go plug in the 0 for the x and the 2 for the x and get out my u bounds now. So when I plug in a 0, this would be 1 minus 0 squared. And when I plug in a 2, this would be 1 minus 2 squared. So this is negative 1/2, 1 to negative 3 of u to the 5th du. Now I can see that the bounds are clearly out of order, so I can flip them. Plus, that's a bonus because then it gets rid of that negative because I have to negate when I flip, but a double negative is a positive. Sweet. And now I can take the antiderivative and evaluate my integral. So like I said, when we are changing, okay, we changed our bounds, we changed everything. When we change our bounds, we don't go back to our x. Got it? Okay, life lesson. So now I go plug it in, and if you want to simplify and get your answer, that's what I got. Okay, let's try the next one. So sometimes you guys, you're going to get used to just not even having to do a U sub on these, but I'm going to take you through a U sub first of the inside and how we would go rewrite all of that. Change our bounds, that would be U. That would now be a 4x of sine U. And then we can take the antiderivative of this. And finish your answer. Oh, shoot, hold on. I wrote sine again. Cosine. Okay, makes sense. Not ask me, sorry. Antiderivative of sine is negative cosine. Okay, now plug in my 4. That would be 1. Plug in my 0. That would be 1. I get out 0. So that's with the U substitution. But let's remember when we took the derivative of sine x or sine u. We would take the derivative of sine and then we multiply by the inside. So now what we're doing is taking the antiderivative of sine, which is the cosine, and taking the instead of multiplying by the derivative of that inside of 2, we're going to divide by it. So if I just wanted to not have to do a u substitution on here, then I can take the antiderivative of the sine, which is negative cosine, and instead of taking this 2x and multiplying by 2, I'm going to divide by the 2. And look at that from now the original x bounds. So it still gives me my same answer with a whole heck of a lot less work. And so whenever I have sines or cosines, only when this inside is linear am I going to just do this little trick, okay? So that's what I'm gonna do. And if you wanna go through the U sub on these, you definitely can. I've showed you how if you need that. Okay, this one gets gross because I have the cubic that is right there. So it sometimes is harder to see. So I'm gonna rewrite and say I know that that means cosine of x cubed. Once I do that, I can clearly see what my u is for the inside. Derivative of cosine, and I can bring the negative out. Hopefully you guys all got to that. But we've got to go change our bounds to u bounds now. So then we say, well, what's the cosine of pi over 3? So go to pi over 3, cosine 1/2, and what's the cosine of pi? -1. Okay. Again, my bounds are out of order, and I've got the negative double bonus by switching them and getting rid of that negative. Finishing the problem, I can now take the antiderivative and evaluate. I do not ever go back to my x. Simplify as much as you would like, unless it's a multiple choice and you have to get it completely simplified. Okay. This next problem is probably the hardest one I'm going to show you. So what's tough about this is that we are going to have to do a heartbreaker, okay? But not in a way that looks very nice on either end, except for I have rules for both now. So I still have that binomial in the denominator, so that's still not something I like very much. But over on this side, I can see that I need to do a lot more work, okay? So I'm gonna wait. But on this side, I can see that my u, the derivative, goes straight to a du, right, of 1. So this side's pretty easy. Let's take care of the easy first. Okay, so I can rewrite that as a power rule. Okay, now I didn't change my bounds. I didn't try to get a numerical value, so I want my final answer to be within the x's still, so I'm going to put what that u was. That one's not too bad. This next one over here is going to be a lot of work. So I don't automatically think of a u sub because they're the same power. But we are going to have to go do that so I don't have the binomial on the bottom. Instead, I get it to the top. So I'm going to let my u be my x plus 4. The u is just dx. So I have this integral now of u to the 1/2 du, but I still have the dx that I never did anything with. Or sorry, the 2x. So what I'm going to do is go solve for x. This is called like this manipulation of variables. And I'm going to plug that into this 2x, into the x. Why did I do that? Because now I can take and rewrite as the power rule for both of those. So I'm going to take my antiderivative, 3/2 divided by 3/2. minus 8u to the 1/2 divided by 1/2 plus c. So now this would be 4/3 u to the 3/2 minus 16 u to the 1/2 plus c. So I'm going to go ahead and get my u. What it was originally was x plus 4 minus the 16. The u here is x plus 4. And I need to put both of these together. I'm going to go ahead and get that in this line. And when I combine my c's, I kind of get this new c. But wait, I can actually combine like terms together. To get to my answer. So I warned you, this one was a lot of work, okay? Kind of threw it in the middle at you. All right, so let's go see one that is a little bit easier. So I have this e, and again, it is with a linear. I'm going to show you the u sub, and then I'm going to show you another way to think about it as well, just like we did with the sine and the cosine. So I'm going to let u now be the inside, which is that exponent. Oops, sorry. So 2x plus 1. Don't need the 2. So I had the 5 that's just kind of going along. I have e to the u, and I have the 1/2 du. I'm going to rewrite like this. So see if all of that is okay. So now the 5/2 comes along for the ride. This is just an easy e now. E to the x, e to the x, e to the u, e to the u, okay? Plus c. I didn't change my bounds, so I'm going to go back to my x. And there we go. Now, that is the long way with the u sub. Just like the sine and the cosine, when this guy is linear, we can do a shortcut. I know that when I did the derivative here, I leave that alone, and then I multiply by the derivative of that linear function. So if I want to take the antiderivative, 5 gets to just go along for the ride, I'm going to leave this alone, and instead of multiplying by 2, I'm going to divide by 2. And do you see how this is exactly the same thing with a whole heck of a lot less work? That will only happen when your exponent is linear. Here, this is not linear. I have to do a u sub. Okay, so first I find my u, take my du, and then see what I need to get it to match. So I needed to get it to match an x squared dx. So I'm going to go ahead and get that 2/3 e to the u du. I need to change my bounds since those are x bounds. So I go and I plug my x bounds in. I get out 0 and 8/2, which is 4. Coefficient goes along for the ride. E to the u, e to the u, just like e to the x, e to the x, from 0 to 4. Change my bounds. I do not go back to my x. So now I can see that's 2/3 e to the 4th minus 2/3 e to the 0, which is 1. And that's u sub. We will want to practice these a lot, okay? Because there's a variety of things, and I know we can do this, okay? See you soon.